Hello everyone. In my previous video, we have discussed Euclid's division lemma, theorem 1.1. In connection to that, today let us do some example questions based on this Euclid's division lemma. This Euclid's division lemma is often called as Euclid's algorithm also, as lemma and algorithm are closely related words. You can use instead of lemma, algorithm also. Okay, according to this question, use Euclid's algorithm to find the HCF of 4052 and 12576. So to find HCF of these two, we need to apply Euclid's algorithm theorem. Okay, first of all, let us recall what is Euclid's algorithm theorem. According to Euclid's algorithm theorem, for any two integers a and b, for any two integers a comma b, a greater than b, remember, there exists two integers q and r, where satisfying the relation a is equal to b times q plus r, where r is the remainder, q is the quotient. So remember, r should be always lying between 0 and b. So 0 less than or equal to r less than b. Okay. Next, let us apply this theorem for 4052 and 12576. So let us think A as 12576, as A should be greater than B. So let us think as B as 4052. And to apply the first step of algorithm, let us divide A and B and find out what are B and R, what are Q and R. Okay, let us divide these two things, 4052, 12,576. Let us divide these two. So for example, if you take 4052 once, what happens? Okay, 4052 times 3 comes the nearest answer, 12,156. So I already worked it out and I have written that directly, not to wasting the time. So 0, 2, 4. So our remainder is 420, and here 3 is called quotient and 420 is the remainder. Now according to our algorithm, we can write the first step as Euclid's division algorithm. You can write the first step using this relation. A is here 12,576 is equal to B times, here B is 4052. 4052 times 3 plus remainder 420. So this is our first step. Okay, let's go to the second step. As the remainder is not 0, we need to continue the division. Let us do the same division, taking 420 as the divisor and previous divisor as our dividend now. So 420 you need to take. 420 times, let us take 9s are, I already worked it out, 429 gives you 3780. Subtract. If you subtract, you are getting 272. So this is our remainder in this case. So here Q is 9 and remainder is 272. Let us write the step 2 now. Let us write step 2 as 4052 is equal to 420 times 9 plus remainder 272. This is our second step. Okay, let's continue the division as our remainder is not still 0. Let's go to step 3 now. Step 3. Let us take the previous remainder what you got as divisor, 272 divide 420. Okay, so previous divisor. So 420 is our remainder now, dividend now. So 272 once, 272, subtract, you'll get 148. So this is our remainder now in this case. So applying division lemma here, you can write it as 420 is equal to 272 times 1 plus remainder 148. Okay, still our remainder is not 0. Let's continue the process. Go to step 4. Take the remainder 148 and do the division again, taking 272 as the dividend now. So 148 times, again 1s are 148. Write 148, subtract. The remainder is here 4, 2, 1. 124 is the remainder. Okay, this is 1 is here again Q. So according to our step 4, we have to write it as 272 is equal to 148 times 1 plus remainder 124. Again, let's continue this process. Step 5. Let us take 124 as the divisor and previous divisor 148 as our dividend. Let's continue. 124 ones are again 124. Our remainder comes 24. So still our remainder is not 0. Let's continue that. According to division lemma, you can write the relation as 148 is equal to 124 times 1 plus remainder 24. Let's continue. Second, coming to step 5 now. Step 6, sorry. Coming to step 6, take 24 as the divisor and 124 as the dividend. Continue the division. 124 5 is 120. Right? 4 is the remainder. So let's continue. What is the relation? 124 is equal to 24 times 5 plus remainder 4. One more step. Step 6 after step 7. Let's continue the division. 4 is a divisor now. 24 is a dividend. Exactly 4 6 are 24. So now you are getting the remainder 0. So you can stop the division at this point and write the last step as 24 is equal to 4 times 6 plus 0. So whenever you got 0 and as remainder, you can take the divisor at this stage. Divisor at this stage as HCF. So our HCF is 4. So like this, you can apply the rule, apply the division lemma and find out all the steps and finally find this HCF. Now you can understand this here. This HCF is the, HCF 4 is HCF of 4 and 6, 4 and 24. HCF of these two digits 24 and 4 is also 4, and similarly this HCF is not only HCF of 4, 24 and 4. This 4 is HCF of these two numbers also, 24 and 124. HCF of 24, 124 is also 4. HCF of 124 and 148 is also 4. So in every step, whatever numbers we have taken as dividend and divisor, HCF of every pair of these two numbers are all HCF is 4 only. Not only the required numbers what he asked in the question. HCF of 4052 and 12,576. HCF is obviously 4 because at the last step we got 4 as a divisor where you got remainder 0. Not only for these two numbers, for every pair of every step, every pair of the divisor and dividend, every pair HCF is 4 only. For every pair HCF is 4. Right? So you can also understand that HCF algorithm works for this finding HCF. This division algorithm works for finding HCF of any pair of numbers. Okay, let's continue the next example problem.